Welcome to the Deep Dive, your shortcut to understanding the research that really matters. If you've ever tried to figure out how hard an athlete is actually working, maybe you're a coach, maybe an athlete yourself.
Or even just tracking your own workout.
Exactly.
Yeah.
It's tough. How do you put a number on effort?
Yeah, and the simplest tool we have, the one that costs nothing, is the rate of perceived exertion, RPE.
Yeah.
It's basically asking someone, hey, on a scale of 0 to 10, how hard does this feel?
Simple enough.
Yeah.
But the debate is always there. Can you really trust that feeling? Does it stack up against, the hard data from a heart rate strap or a GPS unit?
That's the core issue, especially in sports like soccer, with so many different types of activities and training.
Which is precisely what we're getting into today. We're diving deep into youth academy soccer to see if RPE consistently reflects what's actually happening physiologically and physically across different drills.
And we've got a really solid study to guide us through this. It's called Exploring the Physiological and Physical Basis of RPE Responses in Soccer, a comparative analysis of internal and external load determinants across different training drills. Quite a mouthful.
It is. It's by Botan, Anqiang and Yafei Zheng, published in the Journal of Sports Science and Medicine, the 2025 volume. For anyone wanting the specifics, it's volume 24, pages 881 to 890.
And they looked at 46 male academy players, outfielders, average age around 16, so adolescent players.
And they followed them for 2 weeks during their normal training.
Yep, monitoring pretty much everything. They had the players' RPE using that CR10 Borg scale 0 for no effort, 10 for absolute maximum.
Okay.
And then they compared that subjective score against, well, the objective stuff. Internal load, mainly heart rate responses, external load from GPS trackers, so distance, speed, crucially, time spent in high-intensity speed zones.
High-intensity zones.
Yeah, so it's 4 and 5.
Yeah.
And they also measured the player's aerobic fitness using something called VIFT.
VIFT, right. That's the final velocity at the 30-15 intermittent fitness test. It's a pretty standard test in soccer for intermittent aerobic capacity, ability to repeat high-intensity efforts.
Exactly. A good marker for soccer-specific fitness.
Okay, let's unpack this. The big question is, does a player's feeling of effort actually match the data?
Well, let's start with the internal load, the physiological strain. When you look just at that, the answer seems pretty clear.
Which is?
RPE does a remarkably good job. It tracks heart rate, especially average heart rate, really, really well across many types of drills.
So for just gauging cardiovascular stress, it's reliable.
Very reliable. The study found consistently large, sometimes very large, positive correlations between RPE and average heart rate. Think about really intense drills where there's not much stopping.
Like small-sided games.
Exactly. Like the 3v3 small-sided game format they tested, the correlation there with average heart rate was, well, almost perfect. A correlation coefficient of 0.977. That's huge.
Oh, okay. Almost 1-to-1.
Pretty much. Same thing for a muscular endurance circuit they used. Again, incredibly high correlation, 0.968. When the drill demands constant cardiovascular effort, RPE nails it.
And that makes sense from a theoretical standpoint, right? Like the integrated regulation model stuff. RPE isn't just one thing telling your brain how hard it is.
Precisely. It's a synthesis. Your brain gets signals about the effort command going out, and it gets feedback from the body, heart pumping, lungs working, muscles starting to burn, metabolic byproducts building up.
Acidosis and all that.
Yeah. RPE bundles all that together. So when the heart's working hard, that's a massive part of the signal mix.
Okay, so baseline. RPE tracks internal strain well, but it wasn't perfect across all drills, was it? Where did it start to break down?
Right. It got fuzzier when the drills became more, let's say, tactical or complex. Take the 10x5 positional game.
Okay, so more about keeping shape, moving the ball, less about just pure running.
Exactly. In that drill, the link between RPE and average heart rate just fell apart. It was a small correlation and statistically non-significant.
Interesting. So the type of drill immediately changes things. What about the big games?
Similar story, especially with maximum heart rate in the full 11v11 format. The correlation there was tiny, almost zero, non-significant again.
So in those situations where maybe players are pacing themselves more or the cognitive load of tactics is higher, RPE doesn't map as cleanly onto just heart rate alone.
Seems that way. The complexity, the pacing, maybe even the mental effort. It starts to muddy the waters between perceived effort and just pure cardiovascular strain.
Which kind of leads perfectly into the next bit, the player's fitness level.
Ah, yes, the VIFT scores. How fit the player was to begin with.
Here's where it gets really interesting. You'd think fitter players could just work harder, maybe report higher RPEs because they can sustain more.
That's the logical assumption. But in the larger game formats, the 9v9 and the 11v11, the study found the opposite.
Opposite.
Yeah, a large negative correlation between VIFT score and RPE.
Hang on, so the players with better aerobic fitness,
Sure.
the higher VIFT scores, actually reported lower effort in those bigger games.
That's what the data showed. For 9v9, the correlation was negative 0.585, and for 11v11, it was negative 0.446, both statistically significant large negative effects.
But why? If I'm fitter, shouldn't I be able to push closer to my max more often, making it feel harder overall?
It seems to come down to efficiency and how much of their capacity they're actually using.
Huh?
Think about a big 11v11 game. There's lots of jogging, walking, short bursts, tactical positioning.
Right, it's not constant sprinting.
Exactly. So for a player with a really high VIFT, those demands might actually be, well, relatively easy. They're operating well below their maximum aerobic ceiling. They recover faster between efforts.
Ah, so they're more economical. The same workload causes less physiological disruption for them compared to a less fit player who might be redlining just to keep up.
That seems to be the implication. They might have better pacing strategies, smoother movement. They're just less stressed by the typical demands of that format.
So their fitness gives them breathing room, tactically and physiologically. Interesting.
But contrast that immediately with the 3v3 drill. Remember the super intense one?
Yeah, tight space, constant action.
In that drill, the correlation between fitness, VIFT, and RPE flipped. It was small, but positive.
Okay, so there, fitter players felt it slightly more. Or reported higher effort?
Sort of. It suggested in a drill where high intensity is unavoidable and continuous, the fitter players can actually push harder and sustain a higher absolute workload.
Because the drill forces it, and their fitness allows them to tolerate it?
Precisely. So they actually do work at a higher intensity overall, which bumps up their RPE slightly. It's fitness enabling higher effort, rather than fitness reducing the perception of effort, like in the big games.
Fascinating. So the link between fitness and feeling totally depends on whether the activity allows for pacing or demands flat-out work.
Okay, what about the GPS data, the external load? Does RPE tell us how far or fast players are running?
This is where it gets quite messy if you look at the general metrics.
Like total distance covered? Or average speed?
Exactly. Things like total distance per minute or average speed per minute, the relationship between those and RPE was all over the place. Inconsistent.
Very inconsistent. Some drills, like certain small-sided games or a slalom drill, showed decent positive correlations. More distance meant higher RPE. But for others, it was trivial or non-existent. You couldn't reliably use RPE to guess the total volume of running.
And wasn't there another weird finding for the 9v9 game here, too?
Ah, yes. The 9v9 anomaly strikes again. They found a medium negative correlation between RPE and distance covered per minute.
Negative. So players running more distance per minute actually reported lower effort.
That's right. Correlation of mega 0.305. It seems completely backward at first glance.
How do you even explain that?
Well, it probably circles back to that idea of tactical efficiency again. Maybe the players covering more ground aren't just running aimlessly.
They're reading the game better, making smarter runs.
Could be. Maybe they anticipate plays so they cover ground more smoothly with fewer, like, harsh accelerations or decelerations, even if the total distance is high. They're moving intelligently, covering space efficiently, which feels less strenuous than constantly reacting with explosive bursts.
So working smarter, not necessarily harder in terms of peak strain, even if the total distance is greater.
Okay, so general distance is basically a poor indicator for RPE.
Pretty much, yeah. But, and this is a big but, the picture changes completely when you stop looking at total distance and focus only on the high-intensity distance.
Ah, those speed zones again, Z4 and Z5.
Exactly. Zone 4 being about 15 to 19 kilometers, and Zone 5 being anything over 19 kilometer, basically fast running and sprinting.
And what happened there?
A really strong, consistent finding. RPE correlated largely and positively with the distance covered in these high-speed zones across most drills where such running occurred.
So the amount of sprinting or near sprinting players did was a good predictor of how hard they felt they worked.
A very good predictor. For example, back to that intense 3v3 game, the correlation between RPE and distance in Zone 4 was 0.830, and Zone 5 was 0.710, both large and positive. Same for things like repeated sprint training drills.
Why is RPE so sensitive to that specific type of running, but not total distance? What's special about Z4 and Z5? It's about the metabolic cost and the physiological alarm bells that go off. When you're running that fast, you're heavily reliant on anaerobic energy systems.
Less efficient, produces more waste products.
Exactly. You get that rapid buildup of metabolites, like hydrogen ions, which leads to muscle acidosis, that burn feeling. Your breathing rate skyrockets. It's a state the body perceives as highly stressful and demanding. It's impossible to ignore.
It's a qualitatively different kind of effort than just jogging more distance.
Absolutely. Plus, think about the neuromuscular load. Accelerating to over 19 kilometers and then potentially decelerating sharply puts huge stress on muscles and connective tissues. That contributes significantly to the overall feeling of fatigue and exertion.
Okay, that makes a lot of sense. So let's try and tie this all together. What's the main takeaway message from all this data?
The big conclusion, which the researchers confirmed using some pretty sophisticated statistics, linear mixed effects models, basically ways to isolate the key factors.
Filtering out the noise?
Right. The main message is, RPE's meaning is highly drill-specific. It doesn't mean the same thing in every context.
So you can't just take an RPE score from one drill and assume it reflects the same thing as the same score from a different drill.
Not necessarily, especially regarding the external load. The models confirmed that average heart rate was the most consistently strong predictor of RPE overall. Internal strain is key.
Okay.
And, importantly, distance covered at the highest speed. Zone 5 also held up as an independent, significant positive predictor. Sprinting drives RPE.
But things like total distance, average speed, even fitness level in some contexts, their relationship with RPE varies wildly depending on the drill's demands.
Cecily, in those small-sided games or conditioning circuits demanding high intensity, RPE is great for tracking cardiovascular load and high-speed running. But in larger, more tactical formats like 9v9 or 11v11 or positional games, RPE gets complicated.
Because factors like pacing, player efficiency, tactical understanding, maybe even psychological things like focus or stress come into play more.
Yes, RPE is multidimensional. The study didn't measure psychological factors, but they likely influence perception, especially in complex game situations. The LMMs also showed that once you account for heart rate, the direct effect of fitness, VIFT, on RPE became non-significant.
Meaning fitness influences RPE mainly because it reduces the internal physiological strain for a given task.
That seems to be the pathway, yes. Fitter players have lower heart rates for the same work, which leads to lower RPE.
We should also mention the study's limitations, right? Just for context.
Definitely. It's important. This was only a 2-week study, so it's a snapshot, not a long-term view. It focused only on training drills, not actual competitive matches, which might evoke different responses.
And it was with adolescent players, so maturation status wasn't assessed, which could play a role. Plus, they didn't measure things like blood lactate, which would give even more physiological detail.
All true. Important context to keep in mind.
So what does this all mean? For the coaches, the athletes, the listeners trying to make sense of their own training, how should we use RPE?
It means RPE is a valuable, practical tool, absolutely. But you have to be smart about interpreting it. You need context.
Know the drill.
Know the drill. If it's a high-intensity conditioning drill, a high RPE probably means high cardiovascular stress and likely significant high-speed running. That's useful.
But if it's a tactical session, maybe 11v11 pattern play.
A low RPE score in that session doesn't necessarily mean the player wasn't working or wasn't covering ground. It might just mean the intensity demands were lower, or they were being very efficient, or the focus was cognitive rather than purely physical.
So in those cases, you really need to layer the RPE with other information.
Ideally, yes. Combine RPE with heart rate data to check the internal strain, and if possible, GPS data to see if they hit the necessary high-intensity running targets for that session, even if the overall RPE was moderate. RPE tells you how the body felt, but you need other tools to see the full picture of what the body did, especially in complex scenarios.
Right. RPE reflects the internal experience accurately, but it's not always a perfect mirror of the external output, particularly total volume.
Well put.
Okay, so that leads us to a final thought for you, the listener, to chew on. If RPE is so strongly driven by those really high-intensity efforts, the Z4 and Z5 work, does focusing just on total time or total distance in your own workouts mean you might be missing the mark? Maybe you're underestimating the importance of hitting those higher intensity zones, even briefly, for driving that feeling of hard work.
It's something to consider. Perhaps shifting focus from just duration to incorporating peaks of intensity might align better with how our bodies perceive exertion. RPE is a fantastic tool, but like any tool, its power lies in understanding how and when to use it effectively. interpret it alongside the specific demands of the activity.
Absolutely. We definitely encourage you, if you're interested in the nitty-gritty, to check out the full article by Tan, Hu, and Zheng. All the data tables and methods are there. Thanks for joining us on this deep dive.
Make sure to follow the channel and turn on notifications so you don't miss our next exploration into the science behind performance.